In this video, I want to talk about the dot product. The idea is to define some kind of multiplication operation on vectors. So I'm going to start with R2 and then expand this to higher dimensions. To start with, I need to talk about an angle between two vectors. I'm going to define the angle between u and v to be the angle theta, determined by u and v, such that 0 is less than or equal to theta is less than or equal to pi. So here are some examples of vectors and what I would refer to as the angle between them. And while I define this in 2 dimensions, this also expands to 3 dimensions. We can talk about the angle in 3 dimensions between two vectors this exact same way. So I'm going to use this to define what's known as the dot product, u dot v. In this case, we would have the norm of u times the norm of v times cosine of theta. And if either u is equal to the 0 vector or v is equal to the 0 vector, I can't really define an angle theta. So in those cases, we'll say that u dot v is equal to 0. One result of this definition is that the sign of the dot product tells us information about the angle. So if I think about this definition for a dot product, I can divide both sides by the norm of u and the norm of v to get u dot v over the norm of u times the norm of v is equal to cosine theta. And since we know theta is between 0 and pi, then we know that the dot product is positive if theta is acute, since the cosine of acute angle is greater than 0. And we also know if the dot product is negative, then theta is obtuse, since the cosine of an obtuse angle is also negative. So we can determine information about the angle from the dot product. Let's suppose we know that the length of u is 1, the length of v is 2 root 2, and theta is equal to 45. So in this case, u dot v would be equal to the norm of u, which is 1, times the norm of v, 2 root 2, times cosine of theta, which is 45. Well, cosine of 45 degrees is 1 over the square root of 2. And if I simplify this, I get 2. So the dot product of u dot v would be equal to 2. While this geometric version of the dot product can be helpful, for computational purposes, it's really desirable to have a formula that gives us our dot product of the two vectors in terms of components. So we would not have to use our angle theta. Let's consider two vectors u, which is u1, u2, etc. through un, and v, v1, v2, etc. through vn. I want to define the dot product between them just in terms of these components. In this case, u dot v would be equal to u1, v1 plus u2, v2, etc. up through un, vn. So we would multiply things in corresponding positions and then add them up. And you can actually show that in 2 space and 3 space, this form of the dot product is equivalent to our cosine form, the one that talks about the angle between them. So let's look at using this formula. Let's start with an easy one. U is equal to 0, 0, 1, v is equal to 0, 2, 2. In this case, u dot v would be equal to multiplying the first components, 0 times 0, plus multiplying the second components, 0 times 2, plus multiplying the third, 1 times 2. And if we simplify this, we get 0 plus 0 plus 2, or 2. So the dot product u dot v here would be equal to 2. As another example, let's let u be the vector negative 1, 3, 1, 0, v be the vector negative 3, negative 4, 5, 7. In this case, u dot v, I would multiply the first coordinates, negative 1 times negative 3, plus the second coordinates, 3 times negative 4, plus the third coordinates, 1 times 5, plus the fourth coordinates, 0 times 7. So this would be 3 minus 12 plus 5 plus 0, or negative 4. So the dot product here, u dot v, is equal to negative 4.